In this video, we're going to start going through some of the rudiments of trigonometry, and this is going to be one of the large sections that we study throughout our pre-calculus course. So in this section, we're going to start by defining angles, all right? And essentially, we're going to build up our vocabulary with angles, and we're going to define the various terms. We're going to be able to construct angles in standard position. We're going to define both degree and radian measure for angles, and we're going to make sure that we can convert back and forth between degree and radian. We're going to compute the length of an arc on a circle. And then finally, we're going to compute both linear and angular speed. So let's kind of build up our vocabulary a little bit with respect to angles. So an angle is formulated by two rays, and that's going to be the measure that exists between those two rays. And a ray is going to be part of a line that has one endpoint. So if I wanted to construct an angle, this would be a ray, and this would be a ray. Right? So array has a shared endpoint, and this would be our angle. All right, and usually what we do is we call that angle a Greek letter theta. All right, so we're going to see this variable quite frequently throughout the course. Okay, so that's theta when we go to just define an angle. Although there's lots of different ways that we can define angles, this is just the most common one that we use. There's an initial side. So the initial side of this angle would be the one that's on the right, and then a terminal side, which is on the left. And every angle looks different, right? There's positive angles, which are rotated counterclockwise. So the one that I constructed up here, this is a positive angle. However, if I wanted to construct a negative angle, I could do so by going in the opposite direction. And so I might have something like this, where we have we might have like an initial ray. So I'll just draw it like this, okay? And then a terminal ray down here. And if our angle looked like this, if we went that way, and I called that theta, that would be a negative angle, okay? So clockwise in the same direction as a clock usually runs would be negative. Two angles are coterminal if they have the same initial and terminal sides. So if I decided to create an angle that went all the way around like this, and I called that like maybe theta sub 1, that angle would be coterminal to theta, all right, because they basically end and begin at the same rays, all right. It could overlap, and that's perfectly fine, all right. And I could certainly go in a positive direction, and that angle will be coterminal as well, all right. So if I started here and I went around like this in a positive direction, right, that angle would be coterminal as well, all right. And we're going to see later how to compute those as well as construct them, but just giving you the ideas of these definitions as we go through. Standard position is going to start on the positive x-axis. Okay, so the angle right here that's created, that is not in standard position. Okay, so not in standard position, but this angle is in standard position. Okay, and so is this one. Okay, so this is in standard position and this is in standard position because they begin on the positive x-axis. All right, now notice that this is a negative angle and this is going to be a positive angle, right? And remember, the rays meet at the same endpoint, okay? So that has to be given. By the way, another variable that you'll see quite frequently is this one when we're dealing with angles, right? And this is alpha, right? And again, this is our angle theta, all right? So just reminding you of these terms as we're going through, right? Now, there's two different measures that we can utilize when we're going through and trying to qualify these angles. And one of them is degrees, the other one's radians. With a degree, basically that's the amount of rotation between the initial and the terminal sides. And a full rotation of a ray is 360 degrees. Okay, so if I was to draw a Cartesian plane and I was to construct an angle in standard position, okay, this would be 360 degrees, right? And then if I did a half rotation, as we can see below here, that would be 180 degrees. If I did a quarter rotation, that would be 90 degrees, right? And we have special terms for some of these angles that we're going to be looking at. So we need to make sure we understand these terms. So we have acute. Acute means that we're between 0 and 90, I say. So essentially, it's in quadrant 1. An obtuse angle is between 90 and 180. Okay, so that means that it would terminate in quadrant 2. All right, as we can see down here, this is obtuse, this is acute. Okay, and again, if I was to kind of construct these in some sort of Cartesian plane like this, we could see that the acute angle would terminate in quadrant 1, and we would see that an obtuse angle would terminate in quadrant 2, right? Right angles and straight angles, 90 degrees and 180 degrees respectively, they terminate on the axes. So they don't fall in a specific quadrant, they just fall on axes. 90 degrees, right angle, as we just said, 180 degrees, straight angle. Two angles are complementary if their sum is 90 degrees. Okay, so if I had this sort of thing right here, where I called this alpha, and I called that theta, and I called this alpha, I know that alpha plus theta would be 90 degrees in this example, and hence these would be complementary. Supplementary is 180. All right, so if I was to construct, let's just say something like this, okay, or this might be theta and this might be alpha. Alpha plus theta would be a straight angle, which is 180 degrees. Okay, so that would be complementary. And we've already defined standard position. Standard position means that the angle is on the positive x-axis where it starts. Okay, so as we're going through, it's important to make sure that we understand these terms. So we're going to apply all these terms in subsequent videos, but for right now, we just need to make sure that we have a good working vocabulary. So that's degree measure. Radian measure, okay, a little more difficult generally for folks to understand, but not too bad. A radian is a measure of the central angle that intercepts at an arc equal to the length of the radius. Okay, so if we look down here, we have a radius. Okay, so the distance from the center to a point on a circle, and another radius. Okay, the length of that arc is the same as any of the radii. Okay, and that means we get a radian. Okay, which would make sense because they both have sort of that phrase radius embedded within that. On a circle, we can figure out that if we have an arc length S and a radius R, that the measure of the angle in radians would be S over R. Okay, so remember, S is going to be our arc length and R is going to be our radius. Okay, so we just divide the arc length by the radius, and that tells me how many radians we have. Okay, so this would be our radian measure. All right, now remember we had 360 degrees as one of our measures before. Well, 360 degrees is equal to 2 pi, okay? And then, of course, if we divided both sides by 2, that would give us that pi is 180 degrees, okay? So basically, pi radians is equal to 180 degrees. This is going to be the relationship that we should use to convert back and forth between radians and degrees. So if we want to convert from degrees to radians, what we're going to do is we're going to multiply by pi over 180. Okay, so we just take pi over 180, and that converts from degrees to radians. And then if we want to go through and convert from radians to degrees, then we multiply by 180 degrees over pi. So this relationship is going to be really important to us as we go along. Okay? All right, last thing before we conclude this video is just some diagrams with respect to radian measure. We can clearly see that in the diagrams below that we have 1 radian, and then if we have the arc length of 2 radii, okay, so this is actually 2r, okay, that would be 2 radians. And I want you to notice that 3 radians is almost the measure of 180 degrees, okay? But didn't we say that pi was 180 degrees? And most of us probably remember that pi is 3.14159. And so that's why, if we look at this, if I was to just draw a straight angle, that would be 3.14, etc. radians. Okay, so these are really close to one another. This 3 radians is almost pi, all right, which is really 3.14. And again, approximately. Remember, pi is an irrational number, so we can never really figure out what the exact value of pi is, but we can at least kind of understand that 3 radians is almost going to be half of a rotation along our circle. All right, so that's all of our definitions. So key definitions to remember, okay? Basic stuff about angles, okay? So make sure we understand like coterminal, all right, and standard position. We need to know. We need to know about rays, and we certainly need to know about like acute angles. So we need acute and obtuse, right, and straight. And of course, we need to make sure that we understand radian and degree measure. All right. So the next thing we're going to do in subsequent videos is we are going to apply all of these definitions and also the relationships in the angles. So it might be helpful for you to maybe go through, copy down, maybe make some flashcards or something of that nature before we move on. So that way you're very familiar with the terminology. That way when we go through, we say things that we understand what it is that we're actually talking about in our next videos.